In this lecture, we will discuss language considerations. It's really important when we talk about statistical analysis that we consider how we talk about statistical findings. So one of the big things is balancing our confidence with our understanding of uncertainty. Statistics is really about uncertainty, particularly when we're talking about inferential statistics. We're never 100% certain about something, or it's very unlikely that we would ever reach that point. And so for that reason, when communicating data analytic findings to different audiences, it can sometimes be difficult and even challenging to describe findings accurately and with confidence. And so we need to think very carefully about how do we tell a compelling story and make people understand that we're confident in the design that we use, the type of analysis that we use, and our interpretation in the findings, while also making sure that we recognize there is some uncertainty and that we need to make sure that there's some accuracy in terms of describing that uncertainty and that we're not 100% certain that this leads to this or that leads to this or whatever the situation might be. And so really this comes down to making sure that we first avoid overstating our findings and their implications. We also want to make sure, on the other hand, though, that we don't understate them either. And so there's this funny joke that when it comes to working with statistics, and a lot of statisticians, when asked if there is a relationship between two variables, often they'll say, well, it depends. Well, that's really important to consider when you're in that statistical mind frame, but when communicating to outside stakeholders, that sounds like you're maybe not confident in your findings. Now, it's important then to describe that there is a relationship between these two variables, and then describe the size of that relationship, but also making sure to be accurate in terms of not trying to overstate that this relationship, let's say that X explains 100% of the variability in Y. Instead, caution that, well, X explains some of the variability in Y, or X has a strong or let's say a moderate relationship with Y, which implies that it's not a perfect relationship. Now, in addition, when we're talking about the concept of statistical significance and we're communicating this in writing or orally, we wanted to avoid using the word prove or some variation of the words prove, such as proved or proves. And the reason is that prove implies that something is kind of done, that we've already found the absolute answer for something, when in reality we're just making inferences here. And remember, there's going to be sampling error if we're working with inferential statistics and measurement error. And so we're never actually proving anything. Instead, we're lending support to something. And so instead of using the word prove, I recommend that you use words like shows, demonstrates, exhibits, indicates, or suggest, as these have a softer language to them. Now, you can use them still in a manner that shows you have confidence, but it also gets to that point of uncertainty. Saying that something proves something indicates that you are 100% certain that this is why X leads to Y, or that X and Y are associated with one another. Now, in addition, when you hear the word cause or any type of causal language that implies a cause and effect, we really reserve that word for the very rare situations in which we're actually conducting a true experiment, which means that we have random assignment of people to different conditions and that we have a control group. And if we don't have those conditions, then we should really avoid using the word cause. In addition, when we use causal language, we even want to be careful when we're using a true experiment, because when we're trying to understand a causal relationship, it's really more about a body of research and a body of investigations, multiple investigations, as opposed to any one individual piece of research or a study that we've completed or conducted. So if you do use the word cause in the context of a true experimental design and its findings, make sure you proceed with caution. Now, let's move on to this concept of practical significance. So let's assume that you do find a statistically significant effect. Well, then the question becomes, well, how meaningful is that? Or how practically significant is that statistically significant association or difference? And so when describing effect sizes qualitatively, such as using language like small, medium, large, or weak, modest, strong, we want to make sure that we consider the context. And the reason is that in some contexts, we might actually use the qualifier of small, when in other contexts it would be more appropriate to use the qualifier of large to describe that same effect size. And the reason is as follows. So imagine you have a situation, let's say, where you find that a particular safety training intervention reduces the likelihood of accidents and injuries on the job. Well, in that context, maybe we find a Cohen's d of, let's say, 0.1. Well, that's a pretty small effect by normal standards, by universal standards, but in the context of preventing injury, accidents, and ultimately potentially even employee death on the job, well, that even a small effect might actually be quite large when you think about it in this context. Preventing one person out of 1,000 from getting injured or really harmed on the job could be something that's really worthwhile. And so you might want to change your language in that context and say, well, actually, that's a large effect when we're talking about keeping people safe. Now, on the other hand, when you're talking about the relationship between, let's say, employee engagement and performance, you might shift that the other way, where instead of where you would typically call something large, you might say, well, it's more moderate in this context, because you might be keenly aware of the fact that it's not just engagement that's explaining variation in performance, it's also a multitude of other factors, and the stakes are a bit lower in this context. Now, this is something you really need to calibrate within your own HR analytics team and within your organization, and you'll develop your own standards depending upon which area that you're focusing on and what the particular context of the situation might call for. Now, the reason it's important to consider this is that, one, if you understate something and insinuate, for instance, that something is actually just of small effect when actually it could be very consequential if you actually implement this change, well, then people might not listen to it. Now, on the other hand, if you overstate things and seem to imply that, wow, there's a stronger relationship or a more meaningful relationship between these two variables, let's say engagement and performance, then maybe we should actually spend a lot of time focusing on in terms of action, well, then you might lose credibility and also lose your sense of respect from other types of stakeholder groups in the organization. They might not take your HR analytics team seriously from that point forward. So it's really easy to lose that trust and credibility and lose that sense of legitimacy and respect. And so make sure that you carefully calibrate and think very carefully about how you're going to tell the story in terms of what language you're going to use when talking about your statistical findings. Particularly, as I mentioned, when you're talking about statistical significance, as well as when you're talking about practical significance. And really to sum up, number one, avoid using that word prove. Instead, use supports, demonstrates, shows, etc. And also, if you're going to use that word cause, that implies a causal relationship between two variables, use it with caution and really reserve it for instances in which you've used a true experimental design and or you have a whole body of systematic work in which you've investigated something and there's strong theory and strong empirical evidence to suggest that in fact this variable causes changes in the other variable. So again, think very carefully about how you use language in the context of statistics and data analytics. Thank you very much.